All right. This is just a quick little video to go over question one on the homework. We'll cover question two with the next one. So the first part of this question is just sort of diagnosing what the market looks like. And I've already set up some of the graphs here to save us a bit of time. But a couple pieces to point out here, just to diagnose what type of market we're looking at and where it is in time. So first, we have strong demand for bludgers and all types of Quidditch utensils. We also have that the rules are well established and the equipment is standardized. And because of this, sellers produce identical equipment. So we have homogeneity. In addition to homogeneity, we have that bludgers are easy to make. And they sort of require no specialized skills or expensive tools. So it's easy for a new seller to enter the market. So we have easy entry, which is sort of a weaker condition than free entry. In general, we like to think of perfectly competitive markets as having free entry, but in practice, that's almost never the case. So instead, we sort of think about a weaker condition, like easy entry. And then, so the last thing to note here is that the number of sellers of bludgers hadn't changed in quite a long time, so 500 years. Okay, so we'll talk about what happens after the ministry imposes a subsidy on bludgers, which is very similar to what you've seen in Vignette 6. But here, we're going to set up our marginal cost curve. And then let's just draw in our average total cost curve. Now, because we know the number of sellers hadn't changed much in a long time, we know we're in long run equilibrium. So that means firms, there's no entry and exit. Firms don't want to enter, firms don't want to exit. So what this means is there's zero profit. And with the zero profit condition, we get this intersection of the ATC at its minimum with the marginal cost curve at the point of tangency with MR and price. So this is our Q star for the firm. We have all of these things happening all at once in long run equilibrium, which gives us MR equals P star equals ATC equals MC. We've got a lot of things going on there. Okay, so that's the setup. Now, to diagnose what happens with the subsidy, we need to turn to the market. There is a way of thinking about the subsidy from the perspective of the firm. But in general, that's not the easiest way to think about it. And I will not advise you to do it that way. The way we think about subsidies is to turn to the market and look at what happens to prices and quantities at the market level, and then use our understanding of subsidies and how that relates to quantities and prices to then observe what happens to the firm in response to the changes in prices. So just like we do with the tax, we can use a subsidy wedge. We're just sliding the height of the subsidy in from the right, where with a tax we would slide it in from the left. Here we're just taking that idea and applying it to a subsidy. You've all seen this before. Okay. So we need to find the quantity. So this is our Q tau. And let's just mark this Q star here. So this gives us the price for the seller. So the seller, we intersect the Q tau with the supply curve, and that gives us the price for the seller, and then we have the price of the buyer. But the thing to note here is that the price for the seller is what the seller is facing. So when we're finding the solution to the firm's problem, we're going to use the price for the seller. So let's just draw our marginal revenue curve all the way across, which gives us that the solution to the firm's problem at the intersection of MC and MR, call this little q tau. Okay? So in response to the subsidy, the price for the seller has gone up, the price for the buyer has gone down, and the quantity in the market has gone up. We've also seen that the firm is also producing more. So some of this increase in Q is coming from this individual firm. Okay, so the next thing to do is to find profit, and let's just plot this. So at Q tau, we have our ATC. So this is ATC. And we have our price, PS. So our profit is just this area here. It's price minus ATC times Q tau. So this is profit, and profit here is greater than 0. Okay. So the last thing to do is to conclude in long-run equilibrium. So let's find one less color. Maybe we'll do this in pink. Make it dramatic. So what we want to do is shift I'm going to use some fancy iPad tools here. We want to shift this value of the subsidy down until it hits the original price, because we know the original price is where there's no entry and exit. This is where the firms are making 0 profit. So we want the price that the sellers are receiving to equal that. But we also have the subsidy, so we know the price for the buyer is going to be below that PS by the value of the subsidy. So we need to sort of find the quantity where the price for the seller is greater than the price for the buyer by the value of the subsidy, and the price of the seller is equal to the original price, and that happens right here. So I'm just going to drop this, and maybe we'll clean this up a little bit. Okay, so we'll call this PS prime. We'll find PB prime, and this becomes Q tau prime. Okay. So this is our long-run equilibrium for the market, and we need to just label this that when the price goes back to P prime, we're going to shift back in until we get Q tau prime at this quantity. Okay. So let's just write out what we did. Initial equilibrium. So this is step 1. We had P star, Q star, and Q star with a profit equal to 0. Okay. Our second is PS, PB. We had Q tau. We had little q tau, and we had profit greater than 0. And this leads to entry. Firm entry. Okay. And then lastly, we're concluding in long run equilibrium, where here PS prime is equal to P star. We have Q tau prime is greater than Q tau greater than Q star. And let's see. We have Q tau prime equal to Q star, which is less than Q tau. And profits, again, are 0. Okay, it's a little messy, that description, but that will work. Okay, so I think we'll leave it here. This is the solution to homework for question 1.